Okay, so we completed till over here, isn't it? Like how much is the heat dissipated during the charging of capacitor? We told like that when we charge a capacitor, only 50% of not sharing my screen. Okay. Now can you see? Okay, so what we got to know that the energy actually provided by the capacitor is actually CVS square, but the energy stored in the capacitor is half CVS square. So which means that half CVS square, which is half QS square by 2C amount of heat is actually it means the energy of half CVS square is utilized at heat dissipated, isn't it? So let us do one question based upon this heat dissipation and then we'll move ahead. Alright, if there are two plates, okay, and बोल रहा है कि I connect this with a battery. Okay, I connect this with a battery. Question is if this is मतलब बोल रहा है क्वेश्चन कि if initial charge on capacitor, if initial charge on capacitor was CV, okay, was equal to CV बोल रहा है ना? Then if then find the heat dissipated when switch is closed. Let me draw a switch over here. Okay, so बोल रहा है कि find the initial charge if the initial charge on capacitor was C CV and the potential of the battery is V, right or not? Then how much will be the heat? How much will be the heat dissipated? Find the heat dissipated when the switch is closed. बताओ. जल्दी. 2 minutes. सोचो. Okay, so look over here. देखो बता रहा हूँ कैसे होगा. Initial charge on capacitor was given C. Means this battery is developing, okay, plus CV. Means you know that this battery would have this capacitor would have plus Q and this capacitor would have minus Q1 naught. Yeah, so This means that this is plus CV and this is minus CV. Correct, isn't it? So that means that initially the energy of capacitor will be how much? If it is CV, that means the capacitance of the capacitor is C only, isn't it? So initially the energy stored in capacitor is how much? Half CV square, isn't it? Now when you will close the switch, what will happen? What will happen? The charges will start moving towards the battery or not? Yeah. So look over here. Basically, when the switch is closed, then how much amount of charge moves? So this is like discharging of capacitor. So 2 CV amount of, then 2 CV charge charges move across battery or not? That means that when 2 CV charges will move, work done by the battery. How it is? Look over here. From plus, how many we will move? Plus CV. From minus, how many will move? Minus CV. Are you able to get me or not? So this plus CV and minus CV is only generating this battery to be of V potential or not. So work done by the battery will be how much? Charge twice CV into the potential of the battery. So how much is this? Twice CV square. Are you able to get me or not? So initially energy stored is half CV square. Finally the work done by the battery is how much? Twice CV square. Then what will happen? What will happen? Whatever you do, whatever you do, the the means if the initial energy stored was half CV square, and if it also makes the charges to travel and all those things, so whatever you do, the final energy stored will be also same or not? That is equal to how much? Half CV square. Why? Because the capacitor was already charged. Are you able to get me or not? Is that clear? So when the switch is closed, the net heat dissipated will be how much? Is equal to, you know that it will be work done by the battery plus U initial minus U final. Are you able to get me or not? So look over here. This becomes how much? Just equal to twice CV square. So that means that when I connect the battery with a charged capacitor, then the capacitor is not getting sorted. Are you able to get me or not? Capacitor is not doing anything. Nothing is happening on the capacitor. But since it has plus Q and minus something, then the amount of charges which will flow from the battery will be how much? It will be exactly equal to twice CV. And due to that, what happens that whole work which is done by the battery, since the capacitor was already charged, it is converted as the heat energy. Means no energy of the battery is utilized and the battery will go on discharging. Are you able to get me or not? मतलब हम सोचते हैं ना कि अगर किसी चार्ज्ड बॉडी को अगर हम जैसे मोबाइल देखते हो ना, मोबाइल मोबाइल फोन्स, सो यू कनेक्ट मीन्स यू लाइक जैसे तुम चार्ज करते हो मोबाइल फोन को, व्हेन यू आर चार्जिंग द मोबाइल फोन एंड व्हेन इट्स गेट 100% completed, And if you didn't have unplugged it, what does you see? You see that the battery, does the battery go beyond its limit? And does that power plug is creating anything? You will see that after some time that power plug gets heated or not. So that's what is happening. That when the full charge is there, then furthermore charging will not happen, and then the body feels a little bit of what heat over there. Are you able to get me or not? Means all the energy which is supplied gets converted into heat. Is that clear or not? So we completed this sharing of charges. We completed this different types of capacitor. Then we completed this heat generated in the capacitor. Now, let us move on to most important case. And today, we are going to understand how to combine the capacitors. So give the heading: series and parallel combination of capacitors. Okay. So क्या बोल रहा है? Let's suppose let us do the first case, and that is series combination. Is that clear? बोल रहा है कि let's suppose if I take going on taking if I go on taking batteries. Today is 9th, no? 60? 10th. Okay. Tomorrow, should we have class in the evening? Is it possible? Okay. Okay, okay. So Sunday we will start current electricity. Okay, means after doing this series and all, dielectrics and all, Sunday we will start current electricity. Is that okay? And one last lecture after current electricity, after your exams, we'll do some tough questions of this capacitors. Okay. Now look over here. Let's suppose if I connect this capacitor with some kind of battery, then it will supply some charges over here. This is capacitance C1. Let's suppose this is C2, this is C3, this is C4, isn't it? So what will happen? Since the wire is same, the amount of charges moving over here in all the capacitors also it will be what? Same. Are you able to get me? So this is Q, this is Q, this is Q, this is Q. This will be then plus Q minus Q, plus Q minus Q, isn't it? And so on. Are you able to get me or not? Then what will happen? What if it is Q is equal to CV and charges are helping to generate potential over here? So here there will be new potential. Here there will be new potential. Here there will be new potential. Because capacitance are totally different or not. And charges flowing in them are same. So here the potential will be V1, V2, V3, V4 and so on. Are you able to get me or not? So what this will give? This will give me, or this will provide me, we can write this in terms of the resultant capacitance, isn't it? That the total amount of charges which are moving is still same, which is Q, but in between it, I can consider a C equivalent, isn't it? Which will develop, this is plus Q and this is minus Q. Are you able to get me or not? And which will develop between these two ends some kind of equivalent potential, which we call it as V. Are you able to get me or not? So look over here, net potential developed is how much? V will be equal to V1 plus V2 plus V3 and so on. So V will be what? Net V, it will be Q. Q is equal to CV, isn't it? So it will be Q by C equivalent, and that will be equal to 1 by C1 plus 1 by, like, sorry. q by c1 plus q by c2 plus q by c3 and so on. So what I got as a relation, that if I have the capacitors in series connection, then the particular capacitor, net capacitance, is given by 1 by C1 plus 1 by C2 plus 1 by C3 and so on. Are you able to get me or not?
Yes, sir.
Is that clear?
Yes.
Next one is called as parallel connection. Asa, in your school, did they have done charging of capacitor or RC circuit? No, no.
No, I don't think
Okay, so we will do this RC circuit and charging of capacitor after your exam. Why not? Because they will not ask you that, because that is of NEET or JEE syllabus. Okay,
so.
ठीक है ना?
Noted.
So look over here. Now let's suppose if I have parallel combination of capacitors. Sorry. ठीक है? Now,
Okay.
I'm sorry. So let's suppose I passed some charge. Word or not? So this will be Q. The outward coming charge will be Q also or not. But as you know that in parallel connection, current also gets divided. So charges will also get divided.
Yes.
So here it will
Q1,
be Q1,
Q2, like that.
Q2, Q3. But here, as you know that in parallel combination, the potential remains same, isn't it? So in all of these, the V remains same, which is equal to V. And this is, let's suppose, C1, C2, and C3. Is this clear or not?
Yes.
So then we will get my equivalent capacitance, isn't it?
Yes.
Which will have the net potential V and net capacitance C equivalent, such that the charge Q is moving through it. Are you able to get me or not?
Yes.
Is that clear? So look over
Yes.
here. Here charges are getting distributed, but we know that the net charge always remains same. जितना आया उतना बाहर जाएगा. So Q1 plus Q is equal to Q1 plus Q2 plus Q3, isn't it? So this is
Yes.
equal to what? This implies that Q is equal to Q is CV, then C equivalent into V is equal to C1 V plus C2 V plus C3V and so on, isn't it? So therefore I got my C equivalent formula. This implies that C equivalent in parallel connection is C1 plus C2 plus C3 and so on. Are you able to get me or not?
Yes.
Is this perfectly clear?
Yes.
ठीक है? And remember that the ratio of these charges, if it is three connections, so Q1 is to Q2 is to Q3, since potentials are same, they are C1 is to C2 is to C3. Is that clear?
Yeah.
Are you able to get me? So direct
Yes.
formula to find Q1 is what? C1 total charge Q divided by C1 plus C2 plus C3. Are you able to get me or not?
Yeah. This is for parallel connection.
This is only for parallel connection. Because in series connection, charges remain same.
Yeah.
Is that clear?
Yes, sir.
Okay. Okay. So this was about series and parallel. Now let us understand some important cases of it. And one of the most important cases of this capacitor is Wheatstone brace. Is what? Wheatstone brace. Okay. Now
Yeah.
look over here. When I'm considering a Wheatstone brace, the connections are like of this way. Uh, is there any such diagonal? Yes. So you know that in every part we connect a capacitor, isn't it?
Okay.
Yes.
Yeah.
So here also there is a capacitor. This middle line is not there. Okay.
So there are like five capacitors.
Yeah, five capacitors. Now look over here. This is A. This is B. This is, let's suppose, C1. This is C2. This is C3. Oh, okay, 1 minute. Let us write this as C3 and this as C4. Is that clear?
Yeah.
And this is C5. So let's suppose some current will move through this one, isn't it?
Yes.
Q1 and Q2. Is
Yeah.
that clear? Now there is a condition. Let's suppose this is A. This is, if this is A, this will be A also. This will be B also. I call this as C, and I call this as P, and I call this as Q. Got it?
Yes.
तो बोल रहा है कि if, क्या बोल रहा है कंडीशन, कि if C1 into C4, the cross multiplication of capacitance is same and that is equal to C2 into C3, then बोल रहा है potential at P is exactly equal to potential at Q. क्या बोला first point? Potential at point P at is exactly equal to potential at Q. मतलब अगर ये दोनों potential same हो गया, then no charge will flow through the PQ segment or not. So that means C5 have no
No charge.
charge. So basically, we can easily remove it or not.
Yeah. We can remove it.
So we can remove it. Are you able to get me or not?
There is no point putting the capacitors.
Yes. So that means what? What will happen? This will go away. Then these two C1 and C2 will be in series, and C3 and C4 will be in series, and after that you can solve or not.
Yes.
So, but the condition is what? The first important condition is if C1 C4 is equal to C2 C3. This is my first case. Okay. Second case is if V of AP is exactly equal to V of AQ. If V of AP is equal to V of AQ. Are you able to get me or not? Then also
Yes.
the charges will move very less in C5. Are you able to get me or not? So look over here. Let us just try to prove it that what is actually happening. So if V of AP is equal to V of AQ, then what will happen? I can write AP as what? This is Q1 by
C
C1, isn't
one
it?
by C one.
And Q2 by C3, isn't it?
That's right.
Also, like if they are parallelly connected, then V of PB will be exactly equal to V of QB, which implies that it will be how much? If there is no charge through C5, this is what? Q1 by C2
C two.
is exactly equal to Q2 by C4. Are you able to get me or not?
Yes.
So look over here, you got your relation or not? That basically I have to do the cross multiplication, isn't it? So this implies
Yeah.
that if I write Q1 by Q2, then what I will get? So look over here. Q1 by Q2 here is C1 by C3. And here Q1 by Q2 is C2 by C4. So look over here. You got this relation or not? That C1 C4 is equal to C2 C3. Is that clear? So that means that when C1 C4 and C2 C3 are what? Equal, then potential of this line and potential of this line is same. Potential of this line and potential of this line is same. Are you able to get me or not? Is that clear? And this is called as Wheatstone bridge principle. इसको क्या बोलते हैं अपन? That when the C1 C4 is equal to C2 C3, then no charges move through this. So net charge through this is how much? Zero. Are you able to get me? Yeah, yeah. So you can just remove it. Are you able to get me or not? Is that clear? Now look here. Now, to solve any kind of numerical problem in capacitor, basically what we give the capacitance with batteries, isn't it? So to go to many different cases of a series parallel combination, the first thing you'll study is the capacitors with battery. Are you able to get me? So now look over here. Let's suppose if I have any kind of capacitor, I'll draw it little bit big so that to understand in a better sense. May connect that with a battery. Got it or not? Now look over here. This capacitor has, let's suppose this is plus Q and this is minus Q. Got it or not? And the potential of the battery is how much? V. Or let us write E, EMF E. Got it or not? There is a reason for writing E. Current electricity, I'll make you understand why we write it. So right, let's suppose this is E. Are you able to get me or not? Then the total potential of this battery is enough. So what will happen? I can consider this as zero potential and then I can make it as E potential or not. So then what can happen? This can be considered as E potential and this can be also considered as zero potential or not. So for any kind of a capacitor, I can make it E potential and I can consider it zero potential. But there is a condition for that, that here capacitor must be capacitor is charged and it is present in steady state. Are you able to get me or not? So then, if it is capacitor is charged, स्टेडी स्टेट मतलब उसके उसके अंदर से ये चार्ज आउटफ्लो या इनफ्लो नहीं हो रहा है ना. So then the point is the voltage across capacitor when we connect with battery and the capacitor is in steady state is how much? E. Basically voltage across capacitor will become how much? E. Is that clear? Second thing, charge on capacitor in terms of battery will become Q, which will be exactly equal to C. Are you able to get me or not? Which means that no charges flow inside the capacitor. Are you able to get me? Take. Third point, the meaning of this is that when the voltage is developed as E, then what will happen? No charge will flows in the circuit as the what has been developed, the steady state of the capacitance has been reached. Are you able to get me or not?
Yes.
Is that clear? Perfectly clear.
Yeah.
So this is what happens when we have any kind of capacitance in something. If I connect them with the battery or something like that, is that clear or not?
Yes, sir.
ठीक है
हाँ.
आगे बढ़ा जाए
हाँ.
चलो so now look over here let us understand like let us try to do some questions based on these some normal questions first then we'll go to some tedious question are you able to get me
Yes.
so look over here board right let's suppose okay this is the circuit given over here okay and I connect this up with a battery of 10 volts so this is 10 volts this is 12 microfarad this is 8 microfarad this is 6 microfarad and this is 12 microfarad. Question is if this is point A, this is point B. Find the equivalent capacitance first. C equivalent along AB and second charge on each capacitor. Charge on each capacitor. Do it fast. ठीक है जल्दी बनाओ should I help
No, 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 no.
easy peasy जल्दी 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 let us move let us do fast because we have to do handle many types of question okay right or not
So C equivalent is 6 microfarad.
yeah
Like the charge.
C equivalent is how much
6.
6 microfarad correct so look over here this is 6 and 12 so I'll write this as what 1 by 6 plus I can write it directly now
So you get 4 farad in that.
yeah 6 into 12 plus 6 plus 12 how much is this
4 microfarad.
4
4 micro. Sorry. Yeah.
this is 12 into 6
4.
by 18 6 3s are 18 3 4s are 12 so this is 4 now
4, that's what I said.
okay okay Now this is in parallel. So 4 plus 8 is how much? 12. So that means the equivalent is 12 into 12 by 12 plus 12. Isn't it? Similarly, this is 6 microfarads. Are you able to get me? Yeah, you got that. So now charge on each capacitor it is asking. So look over here. Can we say that, let's suppose if here the charge was Q, that will divide into two parts, Q1 and Q2, isn't it? And Q1 and whatever is Q2, that will be same on 6 and 12 or not. So net charge Q will be how much? Q is equal to C equivalent into potential V. C equivalent is how much? 12 microfarad into 10. That is 120 microcoulombs, isn't it? Oh, sorry. What I'm writing? 6 microfarad into 10. So 60 microcoulombs, isn't it? Q1 will be how much? Q1 is, uh, I know my capacitance C1, isn't it? So C1 is how much? 8, 8 microfarad into total charge, I know, which is 60 microcoulombs, isn't it? Divided by, I can apply that parallel connection theorem or not? That if it is two connections, so Q1 is C1 Q divided by C1 plus C2, isn't it? So here C1 here C2 will work like 4 or not. So 8 plus 4. Are you able to get me or not? Is that clear? So how much I am getting? 12 5 is 60. So 8 5 is 40. So this is 40 micro coulombs. Similarly, Q2 will be how much? Q2 will be, here it will be C2 cubes. If this is C1 and this is C2, right or not? C2 is how much? 4. Q is how much? 60 microcoulombs divided by C1 plus C2, which is 8 plus 4, isn't it? So this is just 20 micro. Are you able to get me or not? Is that clear? So we do another question. Okay. बोल रहा है कि uh, if the connection is given like this way between the capacitors, so there are, let's say this is point A, this is point B, okay, and all the capacitances are same, C and C. Then find the equivalent, C equivalent between AB. Now, let's just go now. We will do the another question. Can you do? Do it fast. Sorry. It's easy peasy. If you think you can do it fast. Okay. या मालूम हो गया बताओ या बना लोगे
Just
ओके गो इट that I'll draw this diagram. Tomorrow onwards I'll keep these diagrams ready already. Okay. एक, दो, चार. Acha, this question which I gave you in the like before this question which I'm drawing right now, that question is is look over here. This is something. Look, क्या ध्यान में देखो जरा. It is looking like a Wheatstone bridge or not? That this
it's like a
cross
half
this is equal to
bridge.
this cross this. Yes, correct. So
Yeah,
what will happen? This is like a balanced Wheatstone bridge, isn't it?
yeah,
So if it is a balanced Wheatstone, then what will happen? No charge through this, isn't it?
yes,
Isn't it? So net, look over here. This is these two are in series. So this will be C by 2, isn't it? C by
yeah,
2 में कितना होगा? This is C and C. C plus C means 1 by C plus 1 by C. That means C by 2, isn't it? So net upward is C by 2 and downward will be once again C by 2. And I have to add them. So that will become how much? Exactly equal to C. Are you able to get me out?
net,
Huh. Look over here. This is how much? C by net equivalent of upward is this is going to look like this way or not? Where upward is C by 2, downwards is C by 2. In parallel, I just need to add them or not? C by 2 plus C by 2, which gives me how much? C. That's all. Is that clear?
acha, acha, okay,
Now look over here. There this question is there that all the capacitances are C. Then find the net potential between A and net capacitance between A and B. Yes. So this you do not know. Basically, these kind of questions are done by a special kind of symmetry, which we call it as folding symmetry. What kind of symmetry?
folding symmetry.
Folding symmetry. Are you able to get me or not? Now look over here. Can I just mark these points as P, Q, R, S, uh, P, Q, R, S, उसके बाद क्या बचेगा? R, S, T, U, V, W, X, Y. Are you able to get me or not?
Yes.
Can I mark like this way?
Yeah.
So look over here. If I just connect them parallelly, you know that the potential are same or not?
Yes.
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 Okay. So look over here. When I connect them parallelly and I sort them, see that when I just connect them in parallel connection, what we got to know that their potential used to be always remain same. Are you able to get me?
Yes.
So here we know that potential of P is equal to potential of Q, comma potential of R is equal to potential of S. Is
Yes.
that clear?
That's right.
See, and basically you should remember that this can be folded, means B can be overlapped with A or not.
Yeah.
Yes, and all the points will overlap. So this is why we can fold it. So V of P is equal to V of Q. V of R is equal to V
Yeah.
of S. Similarly, V of T is equal to V of U. Then V of V is equal to V of W, and V of X is equal to V of Y. When all these potentials are same, then the net value of these charges will be what? Zero. Is what? Zero. Is that clear or not? So I'll just get what? Four capacitors in series and another four capacitors in series. So it will look like what? The net resultant circuit will become something like this way. If four capacitors of equivalent value are in series, then the net capacitance in the upward will be C by 4 and downward also it will be how much? C by 4.
C by 4. So we will get 2C by 4.
So this is C by 4, this is C by 4. So net equivalent capacitance is, so this implies C equivalent along AB. If I add C by 4 plus C by 4, it is C by, are you able to get me or not?
Yeah.
So these kind of ladder kind of problem you always solve through which symmetry? Folding symmetry. Which symmetry? Folding symmetry. Are you able to get me?
Yes.
Is that clear?
Yeah.
So remember that you have to always apply folding symmetry to solve this kind of problems. ठीक है?
Huh.
Okay, let us include one more question. बोल रहा है कि this will be a little bit nice question. ठीक है? Let me erase this much please. Question is, if I connect the whole circuit in two parts, okay, so this is 5 coulombs, this is 3 coulombs, this is 2 coulombs. Sorry, what I'm saying, 5C, 3C, 2C, and C. And the EMF of battery is how much? E. Right or not? Question is, what is the voltage. No, no, 1 minute. Look over here. What the point is, voltage across uh, voltage across capacitance C, okay, is 10 volts. Is how much it is?
Yes.
10 volts. Then question is find the EMF of battery. Find the EMF of battery.
What is M?
Okay, right. Find the potential of battery.
Acha. Voltage at C it is 10 volts.
Yes, at C it's 10 volts. Okay.
Okay.
Srishti, earlier our 1.5 an hour session was left out, no? Hello?
Didn't you cover that in diagram?
I covered it.
I think so, according to me.
No, I think I didn't had covered it. Okay. It's good we forgot. It's let us suppose that I didn't forward it. Okay. Okay. So tomorrow I'll take a 2 hour session. Okay.
Okay. Just a instance.
जल्दी बताओ जल्दी. अच्छा, in your school, did they taught you KCL and KVL for capacitor? Means Kirchoff's law for capacitance also?
Yes, yes, yes.
They taught it.
Kirchoff'S.
Uh-huh.
Kirchoff'S, yes.
Okay. So means they told you how to find KCL and KVL and all these kind of things, isn't it?
There is a junction potential.
Potential, yeah, yeah, yeah. Okay. So what we will do today, we will learn through the trick, right or not? Today, I'll teach you the KCL and KVL method with the help of trick, right or not? And tomorrow, with the help of when I'll be completing dielectrics, before that, I'll complete this KCL and KVL on the theoretical basis. Is that clear?
Acha, okay, sir. But actually, that's current electricity bola cha.
So they teach that, that's what I'm asking. Did they taught you the KCL KVL for capacitors also, or did they taught you in current electricity?
They taught us in current electricity, not in
Okay,
capacity.
okay. So I'll do it before only. Let us understand it. For both cases of capacitors and current electricity, means tomorrow I'll do it the full theoretical way, but today I'll do the trick basis. Go ahead or not?
Acha, so here,
Yeah. So can you find what is the current over here? See, this is 10 volts, isn't it?
yeah,
Yes. So now look over
yeah,
here. Let us suppose if this is 10.
here, yeah,
Yeah. So first I'll get this. So let's suppose the voltage across this is how much? If this is Q1, if I supply Q1, sorry, if I supply total charge as Q, and here it is, let's suppose the net current in this part is Q1, and net charge in this part is Q2. Are you able to get me or not?
yes,
Let
yes.
us suppose the voltage across this is V1, and voltage across this is V2, and voltage across V3. This is V3. Are you able to get me or not?
Acha,
Now look here. First point is the charge Q1 across 2C and C will be same or not?
exactly.
Yes. So what is the value of C there? We got the value of C or not? So first point, the charge Q1 across
C.
2C and C
Yeah.
is
MC.
same, isn't it? So this implies हम क्या लिख सकते हैं? इक्वेशन क्या आएगा अपना? कुछ इक्वेशन आ सकता है क्या? Q1 is same over here. This is Q1 also. This is Q1 also. So इसका क्या लिख सकते हैं? 2C into V1 is equal to
2C.
C into 10 or not.
Yes.
So C got cancelled and this implies V1 is equal to how much? 5 volts. So net potential through this is how much? 5. Sorry, this is 5.
Yes.
This is 10. So net potential in this series is how much? 15 or not? Are you able to get
अच्छा
me?
wait wait one second.
See, Q1 is same on this, Q1 is same on this. So this Q1 will be how
Yes,
much?
yes.
2C into V1. This Q1 will be how much?
I
C into 10.
I got that. I got
So
that.
V1 is
I
equal to how much?
understand.
5. Now look over here. If V1 is 5, then this is means this is 5 volts.
Okay.
Okay.
Okay. So Q2 is equal to 10 to 550.
Yeah. So this was V1. So this becomes how much? 10 plus 5 as 15. So net potential over here on this is how much? 15. And in parallel connection, the potential remains same or not?
That's right.
Are you able to get me? So on this,
Yes.
V2 will be also equal to how much? 15 volts. Yes.
Yes. Yes.
And this will be 5 volts. Are you able to get me? So charge Q2.
Yes.
Therefore, the charge Q2 across 3C is simply Q2 की वैल्यू कितनी आ गई? 3C into 15. Are you able to get me?
Yes.
Are you able to get me or not?
Yeah. I
So
got it.
15 threes are how much? 45, no? So
Yes.
this is Q2 is equal to 45. Uh, sorry, Q2 is equal to 45 C. Are you able to get me? So this implies that what? Net charge Q is equal to Q1 plus Q2
Yes.
and Q1 is we got how much? Q1 we got okay Q1 we didn't calculate it. Q1 will be how much? Like multiply C with 10. It is how much? 10C, isn't it?
10C.
Plus Q2 45C. How much is this?
55C.
55C. Is that clear or not?
Yes.
Are you able to get me? So look over here.
Yes.
If I know my total charge, this charge is moving through this 5 coulomb charge or not?
Yes.
So net potential V3 is how much? Q Q is 55C divided by
55 and
5C. C
that is 11 volts.
11 volts. So look over here. On this it is how much? 11.
Yes.
Isn't it? And on this whole circuit, the net potential is how much? Here it is 15. Here it means on this the at the drop points over here and over here. Here it will be 0 volts, isn't it?
Yeah.
Let me just remove those dots. So I'll draw like this way. So I got 11 volts over here on this,
Yes.
and here it should be 0. Here it is 15. Here it is 15. So here it should be how much? 15. So therefore,
15.
V net supplied by battery is how much? 11 plus 15, which is 26 volts.
26 volts.
So what's the EMF of the battery? 26 volts. Are you able to get me?
Yeah.
So you have to go by procedure. See, these questions will not have any kind of trick. You will have to go process by procedure wise procedure. Are you able to get me or not?
Stepwise.
Yeah, that's a perfect English. But I hate English. Got it? ठीक है? आगे बढ़े?
Yeah.
Okay, so we completed this whole. Let us move on to last type of this series, which we solve through the help of trick method. Got it or not?
Yeah.
Now, see, the point is, this is called as loop method. Okay, loop method trick. Are you able to get me or not?
Yes.
The rule is simple. Select two opposite junctions and consider one of the junction to be grounded.
Acha.
Yes. Then marking the other junction to have a random potential. I call it as X. I call it as what? X. Are you able to get me on? Second point
Yeah.
is, as we know, charge coming should be equal to charge
Going.
going. Are you able to get me or not? Or current
Yeah.
I coming is equal to I going
Going.
at any junction, isn't it? For
Yeah.
any kind of a junction. So this junction of marking potential X and charge incoming is equal to charge going or outgoing will provide you the idea that how to find the capacitance and potential of a particular point. Are you able to get me or not?
Yes.
See, so there are two steps. First step is considering one of the two opposite junction, one of the ground, one considering it to be grounded, another making another considering to have potential X, and then apply the concept of charge coming is equal to charge going or I incoming is equal to I outgoing. Are you able to get me at where at which point at the point of junction? Are you able to get me on?
Yes.
So this will provide you the idea how to solve the question. So look over here. Let's understand this question. This trick we can understand through solving some questions, not by looking over there. So look over here. Let me draw. Okay, got it. Okay. So see. Oh, sorry. See that this is trick. Basically, this we are considering as a trick method. Are you able to get me or not? So look
Yeah.
over here. Let's suppose it is said that this is 20 volts. This is 1 microfarad. This is 2 microfarad, and this is also 2 microfarad, and this is 10 volts. Question is, find the charge on each capacitor. Find the charge on each capacitor. Think, then we'll move ahead. Should I solve or you want to do?
Let's see right
Hmm. So look over here, see. See that how to solve it. Let us understand that trick. Now identify the junction. Junction means more than two wires, isn't it? In
now.
general,
Yeah, the one you have
this is one of the junction. These are two equally placed opposite junction or not.
yes,
Then I'll
yes,
consider
right.
one of the junctions to be grounded. Grounded means it will have zero potential or not. Then this end will also have zero potential and this end will also have how much potential? Zero potential.
Yes.
And the another junction point has potential how much?
X potential.
X potential, isn't it? Then here, can I
Yeah.
just consider that from this side, some charges Q1 is going, some charges Q2 is going because there is no incoming over here. So I can just consider outgoing or not. So let's suppose here is Q1, Q2, Q3. Are you able to get me?
Yes.
Now, there is no incoming charge, only outgoing is there. So
Yeah.
that means that since incoming is 0, so can we say that Q1 plus Q2 plus Q3
Plus Q three
is equal to
is
how much?
equal.
0.
Yes. Yes.
Are you able to get me?
Yes.
But what is Q? Q is equal to C V2 minus V1, isn't it?
Yeah.
Yes, यही होगा ना?
Right. Right.
ठीक है.
Right.
So look over here. Let's suppose if I'm this is X. So when I am writing for this Q1, what will be that? Simple. What I will write? C is how much? 1 microfarad. In this circuit, how many capacitors are there? One now. So 1 microfarad. और उसको बोलो हाँ या ना? Then I am starting with which potential? X potential.
X. 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 X.
So X, then I will go ahead, then I will mark minus, X minus. Here I am getting which terminal? Positive terminal first or not?
Yeah.
So then this 20 volts is positive. कैसा है 20 volts? Positive. So V2 minus V1 will
Positive.
be what? X minus 20. Then I again attain 0, so no need to consider 0. Are you able to get me or not?
Yeah.
Plus, for this Q2, this is my Q1. Q2 is how much? See, potential capacitance is 2 microfarads. Potential is X. There is no battery, so X minus directly 0. Are you able to get me or not? Q3.
Yes.
Q3 is 2 microfarads. This is X or not? So X, once again, this is 10. So I'll get plus 10 over here or not? And here it is 0. Are you able to get me?
Yes.
So X minus of V1 is 10 is equal to how much? 0. Are you able to get me or not? So what I got? This is X minus 20 plus 2X plus 2X minus 20 is equal to 0. So this is how much? 4, 5. 5x is equal to 40 and this implies x is equal to how much volts? 20 volts. Is that clear?
So eight. So
8.
how is it?
How much volts? 8.
It's 8 volts.
So x, I got my potential at x or not? Then what is charge q?
That's
Simple now.
find the charge on each capacitor.
8, 1 microfarad into 8 minus 20, isn't it? So how much is this? Minus 12 microcoulombs. Are you able to get me?
Yes.
Minus 12 microcoulombs. Second is Q2, 2 into x. So x is 8, 8 to the 16 microcoulombs. Q3, this is 2 into 8 minus 10. So minus
Minus
4
4
microcoulomb. Are you able to get me or not?
micro.
So the
Yes.
meaning of this minus is that see, this is our convention that charge q1, q2, and q3 are going from the potential x. But actually, this minus sign shows that the direction of q1 is opposite. Got it or not? This minus sign shows what? Direction of q1 is opposite. Direction of q3 is also opposite, and q2 is as it is. So this gives us the idea now that ध्यान से देखो तो total incoming current is how much? 12 minus 4 if I do, it is minus 16 or not? So that means if I just change the direction, it is plus 16, and that is going as Q2, which is 16 microcoulomb. So you got the charges along each capacitor in much more the much most easiest way.
Yeah.
Yes. So this is called as loop rule trick. क्या बोलते हैं इसे अपन? Loop method trick. Consider
Right.
one of the potentials to be at x, another one to be 0. Are you able to get me?
Similarly, we can consider the downward also as x and the upward.
हाँ.
We can also consider the downward as x and the upward as 0. Can we?
Me see, the point is you can consider the downward, but actually people usually prefer to put downward as 0 because the reason is like
There is no capacitor.
नो ऐसा नहीं है, मतलब पॉइंट है कि हम मान सकते हैं बट पॉइंट सेम आएगा, मतलब तुम कैलकुलेट करोगे ना आंसर सेम ही आएगा, बट थोड़ा टीडियस हो जाएगा तुम्हें, मतलब ऐसा देखने में थोड़ा अजीब लगेगा, ऐसे हम डायरेक्टली मान लेते हैं यहाँ पे, समझ में आई बात?
I mean, there is no capacitor also. That
No,
means.
no, no problem. See, if I consider this as x, this as 0, ultimately I'll get a capacitor in this loop. Are you able to get me?
Yeah, yeah. Correct.
Okay. Is that clear?
Yes.
So we'll stop till over here today. Okay.